Hello students, how are you? Hope you're doing well. Now the question is, which device is used to convert AC to DC? State its underlying principle and explain its working. If the frequency of input AC to this device is 60 Hz, then what will be the frequency of the output of this device? So the problem is based on the topic rectifier. The rectifier is used to convert the AC to DC. So the answer of the first line is rectifier. So rectifier converts AC to DC. Rectifier converts AC into DC. This is the answer of the first line of the problem. State its underlying principle. So we have to state the underlying principle. So the underlying principle of the rectifier is using the diode and making the diode on and off. We can explain this with the help of the diagram of the rectifier. So here is the primary side. Here is the secondary side. Suppose we are drawing the diagram of a full wave rectifier. So the diagram of the full wave rectifier looks like this. This is diode D1, this is diode D2, and this is the load resistance. This is the secondary side, and this is the shunt rated transformer. So the underlying principle is to use the diodes and make the diodes on and off in certain cycles of the waveform. For example, we are applying this particular input voltage waveform and we are getting the output voltage waveform between these 2 points as well as these 2 points. So when there is a positive half cycle, the diode D1 conducts, D2 is off, and when the negative cycle comes, diode D2 conducts, D1 is off. So we have to write it down in this particular, for this particular answer, that the underlying principle is to use the diodes and make one of the diode on and one of the diode off. This is the underlying principle. And we have to explain the working then. The working, for the working, we have to draw this particular diagram and explain the working like this. We apply the input signal at the input pair of terminal of the step down transformer, step down center tip transformer. At the secondary side, there are two sections of the windings. The first section of winding goes to the diode D1 and second section of the winding goes to diode D2. In the positive half cycle, the diode D1 conducts, D2 is off, and in the negative half cycle, the diode D2 conducts, D1 is off. So we get the final output voltage waveform like this. So we have to draw the output voltage waveform also to explain the working of this particular rectifier. So this is the working. If the frequency of input AC to this device is 60 Hz, then what will be the frequency of the output of the device? So the frequency of the input voltage waveform with respect to time is 60 Hz. So the output of the full wave rectifier is basically, the frequency of the output of the full wave rectifier is basically 2 times the frequency of the input signal. So if the frequency of the input signal is 60 Hz, then the output voltage waveform of the rectifier corresponds to 120 Hz. So the answer to this part of the problem is 120 Hz. So we can say that we obtain the output as 120 Hz as the final output. So this is the solution of this particular problem. So hope you understand the solution.